Now welcome back to Master Academy of Mathematics. Now this is the next continuation of your higher order ordinary differential equations. If the right hand side looking like e power ax into v, where v stands for either sin ax, cos ax or x to the power of k. So based on that you are going to have this particular procedure. The first step is you are representing the given higher order ordinary differential equation in the symbolic form f of d of y equal to q. You are calculating the complementary function yc by the auxiliary equation f of m equal to 0. Then you are calculating yp. So it is equal to 1 divided by f of d of q. That is equal to 1 divided by f of d, and q stands for e power ax into v. And you are taking only e power ax to the left hand side, so that 1 divided by f of d is converting into f of d plus a. The meaning of this is wherever d is there, you just replace it by d plus a and v as it is. Then you are applying the previous methods based on v. V means either it is sin ax, cos ax or x to the power of k. So based on that you can use the corresponding appropriate method to get your yp values. Then you are calculating the complete solution y equal to yc plus yp. Now let us have a problem. D square y by dx square minus 7 dy by dx plus 6y equal to e power 2x into 1 plus x. Look at the right side. It is looking like e power ax into some v type. So based on that, now I am applying your method. So first you are calculating the auxiliary equation. Shall I write directly? That I am writing in the symbolic form. That symbolic form is nothing but d square minus 7d plus 6 of y, that is equal to e power 2x into 1 plus x. So this is exactly looking like f of d of y is equal to q. So where, what do you think about f of d? It is nothing but d square minus 7d plus 6, and q stands for e power 2x into 1 plus x. This is exactly looking like some e power ax into v type. So once you get that symbolic form, the auxiliary equation is, the formula is f of m equal to 0. So by that directly m square minus 7m plus 6 equal to 0. So we can expect 2 roots for m. It is by the calculator directly you will get the answer 16. So roots are real and both are distinct. Therefore you are getting the complementary solution yc equal to c1 e power 1 into x plus c2 e power 6 into x. Now you are coming to the next part is nothing but yp. The formula 1 divided by f of d of q. It is 1 divided by your f of d means d square minus 7d plus 6, and q stands for e power 2x into 1 plus x. Now I am taking as per the procedure only e power 2x to the left hand side. Wherever d is there, it is replaced by d plus a. Here a stands for 2. So d plus 2 whole square minus 7 into d plus 2 plus 6. And the rest of the term you are keeping as it is. It is equal to e power 2x 1 divided by, so I am just making the simplification, it becomes d square. So here you will get plus 4d. So plus 4d and minus 7d is there. So it is minus 3d. And plus 4, here it is minus 14 and plus 6. So plus 4 plus 6 is nothing but 10, and minus 14, it becomes minus 4. This is of 1 plus x. Now you think about this particular last information. Which method you are using now? So now the right side looking like some x to the power of k type. So you can apply that particular procedure in order to make the complete simplification. Now this is equal to e power 2x as it is. So how to make the simplification? From this you are taking 1 divided by, I am taking minus 4 is common. So that you are getting 1 minus, that becomes d square minus 3d divided by, shall I write only 4 If you want, you can make the simplification like this. Minus 4 into 1, it is minus 4, and minus into minus plus, 4 is cancelled, you will get a d square minus 3d. So this entire value, it is of 1 plus x. Now this is equal to minus e power 2x divided by 4, that I am taking to the numerator, 1 minus d square minus 3d by 4, totally to the power of minus 1 of 1 plus x. Now this is minus e power 2x by 4. It is looking like 1 minus x whole power minus 1. As per the principle, 1 plus d square minus 3d by 4 plus d square minus 3d by 4, it is whole square, and plus so on. This is of 1 plus x. Now just you write down minus e power 2x by 4. I am just making the multiplication. It becomes 1 plus x plus it is 1 by 4. It is common. And what about the d square of 1 plus x? Second derivative. If I take first derivative, that becomes only 1. Second derivative is total, it is 0. So that is 0 minus 3 into first derivative. You will be having only 3. Similarly, it is 1 by 16. It is common. Here you are getting d power 4 is 0. And minus 6d cube, that is also 0. And plus 9d square, that is also 0. So overall 0, rest of the terms are equal to 0. So finally you are getting, it is minus e power 2x by 4. The simplification is 1 plus x minus 3 by 4. So this is about your complete yp value. Once you get yp, you can easily calculate y value is nothing but yc plus yp. Now let us have certain exercise problems. Solve d square plus 2 of y equal to e power x cos x. So right side looking like e power ax into v. So same procedure you apply, and this is your complete solution. And the next problem, d square minus 6d plus 13 of y equal to 8 e power 3x sin 2x. So as usual you find out yc value. And while finding yp, 8 anyhow it is a constant term, you can take it left. And first you take e power 3x right left side, then you apply your procedure for sin 2x. Similarly, d cube minus 3d square plus 3d minus 1 of y equal to x square e power x. Same procedure you apply it and you will get your final answer. So with this, the higher order ordinary differential equation, when the right side looking like e power ax into v, the problems closed. So in the next session, we will enter into the problems right side looking like x into v. Have a good day.